Awesome. Thank you so much. I hope you are all having a wonderful morning, afternoon, wherever you are. We're talking about switch up your expectations with AI-driven switching. We're introducing a brand new switch, the EX4100, with our portfolios today, and I'm very excited to speak about that. My name is Abhisham Sundar. With me today is Rajat Payal. We'll be talking about EX switching as a portfolio. What is Juniper's true north? We've always focused on, as a part of AI-driven enterprise, experience-first networking has always been our most important priority for all products that we've evolved, all the way from the AI-driven wireless, wired, and as well as automated WAN, all trying to solve one important problem, the experience of the user. Why is the application bad? Why is the application experience when a device connected to either wireless, wired? There may be many verticals that may touch as you go along. A packet goes along from the device to the application, and that's the path we are on with getting to experience-first networking. The elements of Juniper, driven by Mist AI, is at its core has Marvis as its AI-driven engine. The elements that make the AI primitives, as we call the SLEs, from Wi-Fi assurance, or the service level expectations from Wi-Fi, wired, and WAN, getting us data from every single device every minute makes us competent for us to get to that answer. If the user is joining the network, wherever the problem may be throughout, our goal is for us to be able to answer this question, and hence AI-driven network for the full stack. Today, we'll be focused primarily on the AI-driven switching portfolio. Well, we're going to talk about a brand new switch that we're going to introduce. I'm going to pass the ball on to Rajat as we go along. And Rajat, if you don't mind introducing yourself and take the ball.
Yes, so pass me the ball and I'll start sharing my screen. My name is Rajat Payal. I am the product manager in the AI-driven campus switching team. So let me take the screen.
We see a screen now.
Wonderful, wonderful. All right. So folks, we have quite a few folks from Juniper here. We have folks from the product management team. We have folks from the technical marketing team. If you have any questions on any of the slides, feel free to put it in the chat, and they'll be happy to answer. Towards the end of the presentation, we will open up this forum for Q&As. So if you don't get some of your questions answered, please feel free to answer it towards the end of the presentation. So what I'm going to present today is I'm going to basically start by briefly talking about our campus switching portfolio, what we have. And then I'm going to talk about the new switches that we recently launched, the EX4100-F and the 4100. But let's start with our campus switching portfolio. And I'm going to start from the left to right, starting with the EX2300, which is our entry-level access switch. It has 12-port fanless flavor, 2448, fixed power supplies and fans. Really targeted towards the small branches and whatnot. Moving up to the mid-tier, we have the EX3400. And what that introduces is it introduces redundant power supplies and fans. So, if any of these PSUs go bad or you need to add something, you can always do that, as a pro. On the premium access, we have the EX4300. 4300 has 1 gig downlinks with 1040 uplinks. And we have the latest, the EX4400, which we introduced last year. It has both GigE and NGig capabilities with 1025 uplinks and 100 gig BC ports. It's a much better hardware, EVP and VXLAN functionalities, PoE++ capability, fast and perpetual PoE capabilities as well on the 4400. So with the EX2300, 3400, 43, and 44, this is really our access, our campus access portfolio. Moving on to the distribution and core, we have the EX4600 and 4650. Again, I'm only highlighting the big differences, because otherwise you won't be able to remember. But the main difference between the 4600 and the 4650 is about speeds and feeds. 4600 is 1040, means downlinks are 10 gig, uplinks can be 1040. On the 4650, we have the 1025 downlinks, and we have up to 100 gigs on the uplinks. For the distribution, you can also use switches from our QFX product lines, the 5110 and the 5120. They do meet the campus use cases, and then they also offer some additional switching flavors or switch flavors, for example, the 10G base Cs and the 3200 gig capability. On the core side, we have the EX2300. This is a modular chassis. Comes in 4, 8, and 14 port line card chassis. It's a Juniper ASIC, and it has different line cards getting towards different capabilities and speeds that you need. So one key takeaway from this slide that I want to highlight is that if you look at these access switches all the way up to distribution QFX 51 and 5120, they all support wired assurance. They can all be managed in Mist Cloud. That's the key takeaway. So our entire access portfolio can be managed in Mist Cloud. And now our distribution and core portfolio, part of it can be managed, and you will actually see the 9200 being managed in Mist Cloud very soon as well. But again, today we want to talk about the new product lines, the EX4100-F and the EX4100. So the EX4100-F, from a form factor standpoint, it offers, again, 12 ports, 24, 48 ports. 12 ports is fanless, compact, built-in power supplies and fans, similar to the 2300, but it offers a lot more capabilities when you compare it to the 2300. Again, it is targeted towards branch locations, but with a lot more capabilities. And I will talk about the benefits of the 4100-F later in my presentation. We also introduced the EX4100. It has redundant power supplies and fans with fixed uplinks. Again, much more capability than the EX3400s. For example, it offers multi-gig capability, PoE++, support for EPN, VXLAN, GBP, MACsec, etc. All right, so let's take a look at these switches and what are some of the features and differentiators, right? So when customers actually buy switches, they're buying switches for 3, 5, 7, and perhaps even more, right? Of course, they have requirements today, but they also want to future-proof the network from some of the use cases that might come in the future, right? So if you look at the wired, one of the key things that drives the requirements on the wired side, the LAN side, the switching side, is actually the wireless. And today, if you look, we already have Wi-Fi 6E. Everybody, whether it's Cisco, Aruba, we at Juniper Mist, we all have Wi-Fi 6E access points. So the transition to Wi-Fi 6E in the enterprise is inevitable. So what does 4100 have to offer, for branch locations and whatnot? So with the EX4100 multi-gig, we have multi-gigs up to 10 gigs and PoE++ capability. Why is that important in the context of Wi-Fi 6E? Well, the reason it is important is because when you talk about Wi-Fi 6E, the access points can push client throughputs in excess of 1 gig, and hence the need for M-gig speeds. And also, for these access points to be fully functional with all the radios and everything, they need more than 30 watts. They need more than 802.3 AT power, and hence the need for BT. So those are the two requirements. And of course, you'll have Wi-Fi 7 coming out. Perhaps it would actually require the same, the M-gig as well as the BT. So from the requirement standpoint, these are the key requirements driving the Wi-Fi 6E transition. And the 4100, M-gig SKU offers both for the branches at very attractive price points. In addition to the 30 watts, there are more and more number of IoT devices coming onto the network. It's not just about badge readers and cameras and whatnot. New facilities that are being deployed. You have connected lighting use cases that are being deployed in the new facilities that will draw power from the switches. There we need not just the power, but we also need some more enhancements on the PoE side. So for example, fast and perpetual PoE. What is fast PoE? Fast PoE is simply, when you power on the switch will supply power to the endpoint. So if you have endpoints connected that need power, switch does not have to wait for the entire OS to boot up. Like, you don't have to wait for the entire OS to boot up for the endpoints to be powered up. The moment you connect the AC power supply, within a few seconds, the endpoints would actually get the power. Perpetual PoE is a capability, let's say you're going through a switch upgrade, a firmware upgrade, or let's say a switch reboot for whatever reason. You do not want your lighting to go out, right? So what perpetual PoE does is it ensures that the power is still being applied or supplied to the endpoints. So on these switches across the portfolio, it doesn't matter 4100 or 4100-F, we will support fast and perpetual PoE. Now, with more and more number of IoT devices coming onto the enterprise, there is a greater need for segmentation. You want to control who can talk to who, what kind of access they have, and hence the need for microsegmentation in the access. So these switches will support group-based policies, and for group-based policies to be supported, you need the EVP and VXLAN infrastructure. So we are extending EVP and VXLAN capability along with GBP down to the 4100-F as well as the 4100 switching families. The next thing that I want to talk about is basically about security. It is top of mind for everybody these days, right? So what we have on the 4100-F and the 4100 is the ability to monitor real-time traffic flows in the hardware. So the benefit of that is that you actually don't tax the hardware resources. You can monitor these traffic flows against security threats. And what that means is that if, let's say, there's a DDoS attack and you're monitoring these flows, if there's an attack, it can actually send that information to an external collector. And once you're notified of the attack, you can take an action. You can automate that. You can, once the threat is detected, you can actually shut the port down. So that's what flow-based telemetry brings in. In addition to detecting security threats, we can actually measure packet delays as packet comes in on the egress, goes out on the egress. So if for whatever reason, there is actually a delay, we can measure that and we can report it, right? So let's say your application is not working fine, there is a slowness, and really we want to find out why it is so. We can get that insight by this capability where we can actually measure the delay, and also we can also figure out why the delay is. Maybe there's a queue that is full. Maybe the CPU is really busy, and hence there is a delay in processing packets. So we can report those packet delays and drop reasons. So that's what the flow visibility is. And in addition to that, we also support the enhanced MACsec. Enhanced meaning we are supporting AES 256 encryption, and that's the key there. The 4100 will support MACsec AES 256 encryption. The MACsec requirements typically in the past was reserved, or rather demanded by federal customers, but we are actually seeing this more and more in the enterprise as well. So 4100 will actually support MACsec encryption on the mGig downlink ports as well as on the uplink ports. Finally, as Abhi said, it's really about client to cloud. And with 4100-F and 4100, one thing that is on the top of the slide, it says is cloud native. What does it really mean? We have heard of cloud ready, cloud native. What is it? So I'll tell you what it means for us. When these switches, when these two product lines were conceived, they were conceived with the Mist Cloud. It was not an afterthought. So what does it translate to? Better boot time, right? Because you want to onboard these switches faster. When you make config changes, you want those changes to be reflected almost in real time in the Mist Cloud. You will get that with the 4100s, right? You will get the same seamless day zero experience that we today have with the EX4400 and some of the other switches. When we ship the switches, there is no gap when it comes to wired assurance. Just because it is new doesn't mean that it's going to have gap and we'll cover it up. There is no gap when it comes to the kind of functionality, the features and functionality that we support from the Mist Cloud. All the Marvis SLEs that we have will be supported on 4100 and the 4100-F at FRS. So that's what I really mean by it is cloud native. All right, so I'm gonna go into some of the details of the switches in terms of the different flavors, the speeds and feeds, what the PoE budget is and whatnot. So on the EX4100, we have the 24 port and the 48 port flavor. We have the GIGI and the multi-gig switches. Again, just a reminder, these have dual redundant power supplies and fans. Yeah, they support 10 members in a virtual chassis. I think Juniper was the first one that supports 10 members in a virtual chassis, and we are ensuring that on the 4100 we support the same. In terms of the different SKUs, we have the 1 gig, 40, 24 and 48 P's and T's, and we have the multi-gig 24 ports and 48 ports. In terms of the multi-gig ports, the 48 port has 16 ports of 2.5 gig and 32 ports of 1 gig. On the 24 ports, we have 8 ports of 2.5, 5, and 10 gig, and 16 gig of 1 gig. For stacking, we have 4 ports of 25 gig, which are default VC ports. And in addition, and this is the key here, we are not reusing the VC ports for uplinks. We have 4 ports of 25 gig, which will be default VC ports, when the box ships out of the factory. In addition, we have 4 ports of 10 gig for uplinks. Okay, so a total of 8 ports. And I'll show you the picture as well to visualize. The VC ports can also be used as uplinks. So let's say if you wanted to convert the VC ports and you wanted to use a 25 gig uplink, you can do that. In terms of the PoE budget, the 1 gig SKUs will support PoE Plus up to 1440 watts with 2 PSUs. The multi-gig SKUs will support 1620 watts of PoE Plus up to 90 watts. So what does it mean? It means that on the multi-gig SKUs, you can have 27 ports of 60 watts each. All right, so let's take a look at the 4100 24 ports and 48 M gig, and that's what I'm showing you here on the screen. So as I said, on the 48 ports, the first 16 are the M gig ports, the next 32 are the 1 gig, and then you have the 4 25 gig VC ports, followed by the 4 10 gig uplink. Again, the key thing is that you actually have 4 VC and 4 uplinks here. All right, let's take a look at the 4100-F. So as I said, we have a compact fanless 12 port, and then we have the 24 ports and the 48 port 1 gig SKUs. In terms of the stacking capability, it has 4 ports of 10 gig for VC. And again, in addition to that, it has 4 ports of 10 gig for uplinks. On the compact, we have 4 ports of 10 gigs for VC, same as 48 and 24 ports, but we have 2 ports of 10 gig for the uplinks. And I'm going to show you the visualization for the compact as well. So if you look on the screen here, you have the VC port, the 4x10 in the front, SFE plus ports, and you have the 2x10 uplink ports at the back, and they support 100M, 1 gig, 2.5 gig, 5 gig speeds as well. All the ports in the front of the switch, the downlink ports, support PoE plus power. One key thing that I want to highlight, actually there are 2 things. One is that even on the 4100-F portfolio, we will support up to 10. And why am I mentioning that? Because I showed you the 2300. 2300 supports 4 members in a virtual chassis. But now what we have done is across our portfolio, whether it's a 4100-F, 4100, or the 4400, which we introduced last year, all of these switches will support 10 members in a virtual chassis. The second thing that I want to highlight here is that the 12-port switch, the PoE switch, can be powered from a BT power source. So for example, you can connect this 12-port PoE switch to an upstream, say a 4400 switch, which also supports PoE++. So you don't need an external power adapter to power this switch. If you have some power challenges, you can connect the 12-port PoE switch to an upstream switch that is capable of providing 90 watts. And you can utilize both of these uplinks to connect to an upstream switch. And if you do that, you can actually also get PoE out from the switch. So you can have access points connecting to the switch while the switch is drawing power from an upstream switch. With the combination of AC power supply and the uplinks connected to, let's say, an upstream PSE, we can support a total power budget, PoE budget of 300 watts. All right. I just want to double click on the virtual chassis again. As I said, 10 members in a virtual chassis across the portfolio, dedicated VC ports on both the 4100 and the 4100-F. Different flavors of optics. If you want to extend, your VC out to a different building, you can do that. You're not restricted with a certain cable length. You can go as far as 10 kilometers, I guess. And there is no restriction between, virtual chassis can be formed only with the 4100 or the 4100-F. You can do a mix and match. So there is no limitation there as well. All right. I also want to touch base on the branch architecture, because these switches, the 4100 and the 4100-F, both are really targeted towards the branches. So whether you have a very small, simple branch architecture with access points, switch, and an SRX for WAN, or you have a bunch of switches which are in a virtual chassis, like a mid-sized branch, or even if you have a small campus or a large branch where you have multiple switches in a virtual chassis and access points connected to that, and, all of these architectures can be sufficed by both these product lines, the 4100 and the 4100-F. At this point, I'm going to hand it over to Abhi. But as I said, if you have any questions, please post in the chat. And at the end of the Abhi session, we will open it up for Q&As, live Q&As. Thank you.
Perfect. Thank you so much, Rajat. That was awesome. We introduced a brand new product. We've spoken about the speeds and feeds, which is very important. There were a lot of questions on memory and storage. I hope we've answered all of these questions. We've taken immense care getting to that part. Now, there are elements of what 4400 can offer more in terms of a campus architecture. You're running 4100s in the campus architecture. Now, natively with MIST, we support configurations, all the three architectures that are in front of you in the screen. This is talking about EVPN multi-homing. This is an architecture where we are able to use your existing access layer, keeping them L2, and then replacing older technologies where you had to do either NC lag or any other new technologies. Instead, you can go the route of EVPN multi-home underneath. It uses the standard space ESI lag. So that's one aspect if you're a small, medium campus. If you're a larger campus, HQs, if you'd like to keep your L2 the same as they are today, and not be able to one element between the architecture on your middle and the architecture on your right, the big difference is where the fabric extends to. You see the yellow box. We're talking about where will the fabric be extended to. It's a traditional spine leaf connectivity in the middle, which is the campus fabric core distribution. Your layer 2s will still stay layer 2s and just have a ESI lag towards any of the distribution switches. Now, if you'd like to use the advantage of GBP, which is group-based policies, we'll talk about it a little bit. You'll be extending your fabric all the way to the axis. That means routing at the axis, you have all of your hosts, you learn tags, and then your policies would be as simple as you saying tag A can talk to tag B, or tag B cannot talk to tag A, and vice versa. And that's the intention behind helping making segmentation better with the new tech, which is the IP Clove, which is all the way on your right. And 4100 would play very well in all of these architectures as your access layer switch. Now, let's talk about group-based policies a little bit. Group-based policies are our standards-based segmentation that are dedicated for us to be able to say, if we'd like to have micro-segmentation in picture. When you say micro-segmentation, we're talking about intra-VLAN segmentation as well. You'd like for all the cameras to talk to the video server, but you don't want the cameras to talk to each other. That's a good example. Or same would be if you're running a hospital. If you have different IoT devices that connect to the network, you wouldn't want them be able to connect to everything else. The older ACEs/ACLs or even firewall filters would only scale so far, and that's where we help manage this better with the help of group-based policies. Eventually, the end goal is whenever a device comes online, talks to a radio server, gets itself a tag based on the nature of the devices, and then subsequently you will define what tag can talk to what tag. And there was a question online about what is the policy manager for all of this. There is work in progress. Eventually, the goal would be for you to have a centralized policy management, which would be on Mist, and subsequently the policy enforcement will be happening locally closest to the source, which is the switches themselves on the 4100s. So we'll talk about campus architecture quickly. We want to talk about how will you bring campus fabrics, and it's new technology for a lot of us. When you bring in new protocols, it involves EVPN, which is MPBGP. You also have to learn VXLAN. There is an element that we brought about to say, how can we make this easy with Mist? In the next upcoming demo, one thing I will do is we'll focus on what is the day 0, day 1, and day 2 story for all things, even branch networks, as well as campuses. And subsequently, we'll end with how do we build a campus fabric just with Mist as a campus fabric builder for you. Let's talk about onboarding. We spoke about day 0. We said, we're going to make wired assurance as a portfolio that comes on top as a solution for you alongside the 4100. Is primarily focused on automating all steps of your deployment. We talk about onboarding. We talk about configuration at large in terms of how do we configure large number of devices, and subsequently also monitoring, troubleshooting, all of these aspects. Let's talk about onboarding as an element. Every single device that is shipped out today, including the 4100s, are all shipped out with a claim code right there on the box. As an installer, whoever is installing, all they would need is an app. This is a representation or video of what the installer is doing on their app. So you select the site of choice, you log in and say, claim my devices to the network. And then as soon as you see the code right there, you would be able to actually see that the device has been claimed successfully. So all you did was you scanned your QR code onto the device, and every device goes out with the QR code. Now the device is available for you to configure from the switch, from the Mist dashboard. Your device is not plugged in yet, not powered, racked, or stacked, none of those, but you're already able to configure them. You can go in as an installer, also assign these devices into a site of your choice, and subsequently, our configuration model will help you build the entire network for you. You can also take a picture of where the switch was installed, and name the switch if you're going to. So the goal for an installer role is for us to make the onboarding process easy. What happens after the onboarding is done? Once the onboarding is complete, the next piece of the story is for us to be able to say, let's go into the actual onboarded device itself. The onboarded device is the 4100-MFT that is listed here. It's disconnected. What do you do with the switch? You can actually start configuring these devices even before they're brought up. They start talking to the cloud, and that's where we go into the aspect of going in and going in and configuring these devices as per your requirement. It's in disconnected state, but it's ready for configuration. In this example, it's a simple one. We go in and add a name to the switch. We've built templates. We've also added we have a lot more. We can talk about how do you build templates, which makes life very easy. But the templates are already built out. And for you to say all the devices needs is it will need it will need for us to be able to talk to the cloud right after. Project made one important point. He said it's born in the cloud. What is it that brings in? Here's an example of a live 4100 switch. You see the switches are lit up. The aspect of what this brings in is every switch now also has a cloud LED. The cloud LED, in this particular case, if you observe closely, it's actually blinking thrice. If you're familiar with NIST, the codes are very simple. 1, 2, 3, a bunch of blinks that you can look at. 1, 2 blinks, there's no Ethernet link. 3 blinks, there's no IP address. This device is telling you that it's not able to talk to the cloud because this is the page right here where you can see it's not able to talk to the cloud, and here's why. An installer looking at it immediately will know that there's something upstream that's wrong, that I'm not able to get an IP. You don't have to console in, and that's our goal eventually. Not for you to have to bootstrap every single device that comes on board, not for you to have every device that needs to go in, console in, and have a bunch of copy and paste commands changing IP addresses. Trying to go away from it and say, how can we make this simple for you? And this is an AP pattern which says no IP address because it was 3 blinking lights. So, so the deployment part of the story, let's get into how you would deploy these networks. The devices themselves, once you connect to the cloud, they will immediately call the phone home process, which is what you would need for the devices to actually call home. All it would need is to get an IP and be able to resolve any addresses. So as part of your DHCP options, please go ahead and send us all of the elements that are required for the switch to come up. So for example, you'd send us not only the default router, but also DNS server so we can reach out to the cloud. Barring those are the only 2 requirements. As soon as it reaches to the cloud, it will get all the configs you configure for the device automatically. And here we also use the feature of dynamic port profiles, wherein we said if a device matches a particular LLDP pattern, for example, in this case, we said if my device is a mistake P, it always says my LLDP description is starting with MIST. So you would immediately say, I'd like to onboard the device, and the device is given the AP profile. The AP profile would be a trunk profile, and it would just pass a bunch of USB lines. We don't want you to get in the business of having to click on every port every time it comes along, every time a device comes along. We did a webinar yesterday. One of our customers who's embarked on this journey and gotten to this point, you definitely can take a look at that. This is about the K-12 webinar, but they spoke about how they have come into a point where every port is dynamic in a sense where either it's .1 export or a port that's just native dynamic port profiling directly from the NIST cloud.
Abhi, I have 2 questions for you here. If you can, what if I have multiple switches? Is there a mechanism to onboard them rather than having the installer scan the QR code on individual switches? That's question number 1. And question number 2 is, what about virtual chassis? If I just stack up all my switches, how do you onboard them into NIST cloud? So if you can just briefly touch on those 2 topics.
Awesome. 2 very important questions, and thanks, Rajat, for that. Now, every single device, you don't have to go in and clean them. As part of your purchase order, you get 1 single activation code. You may have ordered 100 switches, about 500 APs. You're not in the business of cleaning each one of them every single time. You get 1 single activation code, you plug that into the mesh dashboard, all of your 100 switches and 500 APs are right there ready for you to get configured. Now, the devices can be onboarded, and once they are, you can also use our templatization mechanism, and you can fully configure these devices. Now, post this, the second part of the question, the most important one, is virtual chassis. You can actually stack up to 10 members on a 4100. What that would also mean is they also come with default VCPs or VC ports. You stack them together. If you have a choice of who needs to be the active and who needs to be the backup, just put them up first and put the rest of the line cards later. Stack them all together. They form a stack automatically. Plug in the uplink cable. They will reach the cloud as a VC. You're not in the business of configuring any aspects of how do you bring the VC. Rather, the Mist cloud will recognize you as a VC, and we go right away after. Great questions. So having said that, let's go into a live demonstration of how a campus fabric would look like. Now, in this example, I have multi-homing already delivered, as in I've created a simple multi-homing setup in here. Now, as a daily operation, a couple of things that you would do is you either add new segments or new VLANs, or you would also do addition of new access switches. And that's the profile that I would walk you through right now. So you'd say edit the config. It's already set up for you. And this is the exact same flow you would do even if the first time you're building out the fabric. As you can see on the top, it has 4 important steps for you to go through. You tell us what topology you're building. Smaller cases, you're talking about EVPN multi-homing scenario where you could have redundancy if one of the cores go down as well. In a collapse core scenario. And subsequently, you can do the same thing with campus fabric core distribution or IP core as well. Now, the elements that are part of this flow. So you're telling me that there are 2 collapse cores and 2 access switches. Now, the first time you would have done is just add switches. We'll do the exact same thing. Let's go in and add our 4100 from the network. So you click on the 4100 and select. So you now have added an additional switch into the network. Subsequently, the next step is tell us what VLANs you care about. I pre-populated them for you so that you don't have to go through the entire process. But it would be as simple as you creating a new network. Say this is my camera VLAN, and this is VLAN ID 100. And if you'd like to, it's probably another one already. Let's go say 105, and then off you go. You tell us you're going to advertise all of these networks, and they're transferred off link automatically to you. If you care about segmentation in terms of VRF, you can segment them here as well. You can say, I have a brand new VLAN, and I'd like to segment that with the new camera, and say I'm going to call that a camera VRF. Now, subsequently, you've done all of these elements of identifying the nodes that you care about, the VLANs and the VRFs that you care about. And the next part is you've added a brand new switch. You tell us how it is connected to the cores. In a multi-homing topology, each access switch is connecting to 2 collapse cores. So how are they connected? So you click on the access switch. You tell us I'm connecting to the core. C port, same thing on the unique 2 ports that are going to 2 different devices, and go back to the cores as well and say, I'd like for my access connection to the brand new switch to be here. So go to both the cores and tell us what the connections are, and off you go. Now, you told us that 4100 resides here, and they're connected this way. Notice all the things that we did during this process was be able to identify the topology of choice, tell us what elements belong here or the nodes, and then what networks do we care about. All elements that you are very familiar with even today. And that would end our process of build out of the entire fabric for you in terms of us adding the new VLAN across all switches, as well as adding a brand new switch onto the network. And you can say apply changes. Once you apply changes, you will be able to say my devices would come up. If some things are broken, we will tell you that there are elements that is not connected properly. Right here, right away on the screen, I chose random ports. We are telling you that there's a problem. There's no connectivity between the devices that you told us that it would be. Go fix it. So if there's a problem in the network, the topology tells you when there's a problem. But regardless, you can actually go in into the switches. My favorite part is the fact that you can actually read into what we are pushing out as part of every single device's configuration. especially for a lot of people I saw on the chat are very experienced Junos personnel. And if you still like to see your Junos configuration, you can. Every single device, you can actually look up the configuration, and the configs are right here. They're all available in the set format. We wrote about all the different VLANs that we configured. Here's the VLAN that we just added. And the assignment of ports, you can assign them from the template directly so that you don't have to manually click on every single port. You can do it dynamically by doing dynamic port configs, like as they are mentioned here, the same LLDP description. It starts with NIST with the AP profile. And port profiles are the de facto standard of personas that is listed here to say my port of AP looks like this. It's a port is enabled. You can add a description. It's strong. The default port network is one in this case. You can make them any other VLAN if you'd like to. And subsequently, do you want to trunk all networks? What is the speed, duplex? Any interface parameter you can think of, even some of the security elements. What is the MAC limit? Do I anticipate use on them? All of them are available for you to configure as part of the port profile. So subsequently, you can say, I've already done the hard work of configuring the port profile once in your template. You can go in, choose all the ports of choice, and say, I'd like to push in the configuration to say, this is no longer the default profile. I'd like for them to be .1x, and you save. And subsequently, the configuration changes again. The .1x implementation is very simple as well. You can see you push down radio servers, tell us what the shared secret is, and off we go. So 4100 is one in the cloud, but also is fully active for you to fully configure, manage all of these devices natively from the cloud. You can manage for your branch case scenario. You can manage to your, excuse me, you can manage for your small, medium campuses as well. If you're migrating, going away from older dual homing technologies and moving towards the open standard of like an ESI lag, even in a smaller setup, we can help you do that. And all IRB, which we just demonstrated. Hopefully, this gives you a brief start on and all things that we can do as the power of the switch that is born in the cloud, that's 4100, as well as the cloud itself, which is just displayed as to how you're able to configure at scale, as well as configure elements that are deemed difficult, but now we can make it easy with these management. I think we have given we've left fair enough time for conversations and Q&A. We'll be happy to take a few questions. Any other thoughts on it? I think there's a good question online. Speaks about how do you onboard an access switch where there's the aggregation link is actually a port channel, or there is a lag in this case. There is an element in Junos, which is known as the link aggregation force up. You can enable that on your aggregation switch on one of the ports. The port channel will come up, and then subsequently, once the devices are on board, you can go ahead and take them out. But it is an important part of the story for us to bring up VCs. There are uplinks that are connecting to different members of the VCs. Absolutely, this is an important one, and we've actually faced these scenarios in the field. Please do try out the force up function on one of the ports only, not all ports. So not all ports for it to be link aggregation force up. But it's ready. You can do that today. After I claim the switch, do not show in the switch tab only in the inventory. Correct. So if you just claim the switch, you go into the inventory view. That's a good question. If you there are two aspects of claiming the switch. You can go in and say you put the claim code in and you can claim it. Once you claim the switch, there is an element in here which says assign to the site. If these boxes are unchecked, then you don't see anything. It'll just be sitting in the inventory. And the same is the case for the brownfield onboarding as well. If you've not seen the brownfield onboarding on all of your existing 2300s, 3400s, 4300s, 4400s, all of them can be adopted in Linux Cloud by adopting these 5 lines of configuration or 7 lines of config, which basically is outbound SSH, a connection from the device outbound to the cloud, they will come sit here in the inventory, and you take into the you can go in subsequently and say, oh, I'd like for that switch to be assigned to site X, and that's where you go in and assign the site wherever you'd like to. And if you're moving from one site to the other, you want to ask for a question whether you want to retain all configs or you don't. So there's enough flexibility in the system as to how you can do that. The FedRAMP portion is work in progress. Cool. Any other questions? Yeah, by default, there's a question about, can we use VC ports to be used as network ports on the 4100 and the 4100Fs? You absolutely can. It's a function of you go changing the config for them to move away from being a VCP to a regular port. And if you're only standing up standalone switches, if you'd like to make use of more offerings, that's definitely an option you can adopt. There has been no EOLs for 2300s and or 3400s. These are strategically placed, as Rajat went through. These are placed to give you the elements of one in the cloud, as well as the new functions that Rajat spoke about. The elements of us being able to get flow-based telemetry from the hardware, gather security issues. This is a
yeah. So Kevin, in summary, there are no plans to EOL 23 and 3400s. Absolutely no plans right now.
Eric, reach out to me or customer support. We'd like to see what's going on. We haven't seen that issue where you see it in the inventory and not in the switch directly beside it. But happy to take just open a support ticket on your top right, say support. Somebody will jump on the call immediately. All great questions, by the way. We can hang around for more questions, or feel free to find us on LinkedIn. We'll be happy to help in any way possible. Cool. I guess there are no other questions. We can go ahead and close this out. Again, on behalf of both Rajat and me, thank you so very much for taking time to looking at our brand new switch. And also, hopefully, you got enough information about how you can utilize Mist to make this come to life and make your life easier for day 0, day 1, and day 2 operations.
Just the last question, Abhi. If there's a question on DPC, dynamic port configurations. It says, is there more details on this?
Actually, let's go through it. We have a few minutes. Let's talk about that. So dynamic port profiles are our incarnation for us to try and limit the amount of configuration that you have to do every time you bring the switch on. And that, in a sense, if you look at the templates themselves, let's start with the switch templates. You can look at any one of these templates. This is a live demo. There's a host of things that we've done. The dynamic ports is basically an assertion for us to say, let the device identify itself. And the identification has a bunch of rules that you can adopt. For example, I'd like for any device that matches the LLDP description of, let's just say, access. This is a popular one that we have seen in the field. I didn't want to give you an example of Mist APs and think if you only work with Mist APs, but absolutely, you can do LLDP description. Go look at your switch and do show LLDP interfaces, and then do the exact interface of choice. There's a description field there. Pick up the first word that is there. You can put that here, and any device of the same camera, let's say in this example, they're all cameras. You can go in and put in the profile of camera, for example. Similarly, you can also utilize any of the LLDP fields. We support a host mode. In the API world, on the UI, you can see you're supporting system name, description, and chassis. We can also utilize radius filter IDs or radius usernames for you to actually put them on a particular port. Last but not least, if none of these actually meet your criteria, this is the last resort, you can basically say to Mac, you can pick up the physics, the OUI, and say the OUI of this particular device, these kinds of devices all start with XXXX, and then I'll apply the profile for you. And this can be distributed across multitudes of sites and across multitudes of switches. So we have customers over, the Juniper network, for example, has over 47 sites. They run it with 2 templates. And all of that is primarily focused on how do you run the templates, and also making their life easy for the same kind of devices that keep coming in different sites, and that's the instantiation of dynamic port configuration, and that's how that comes to life.
Thank you, Abhay.
That is correct, Starlin. If a switch is just placed in the inventory and it's not assigned to a site, it will not receive any config. It will just sit in the inventory as unassigned. There's a couple of elements I think we can touch upon just before we close out. I said day 2. There's a host of things that we do. If you've seen wireless, we've always been pioneers in saying, how do we tell what the health of your network is from a perspective of the client? And you see a host of things that wireless is more dynamic. A lot of things involved, including how your roaming is, what the coverage looks like. Same constructs were brought to from the wired world as well. What is the status of your network from a client's experience perspective? We said experience-first networking. We wanted to make sure you bring this into the table. So if you look at the throughput by itself as an SLE, there's a host of things that can go wrong from a device perspective. And you're looking at, let's say a scale of, if you have 1,000 devices in a network, each of them 48 ports, you're looking at 50,000 ports in a network. How many devices at this point is actually showcasing that cable behavior? Within 2 clicks of that screen, we have now come down to exactly the interface, which is gig 0023, on the switch, which is LED switch 1 on the network. And that's the power of us being able to gather telemetry from each of these switches and identify issues for you. Layer 1, layer 2, those are all classified under interface anomalies. If there's a device connected, that's, for example, a card reader, and it's only speaking at 10 tap, or it can only speak at 10 tap, but you unfortunately configure it as, one full or auto, and it's not working. We'll tell you that it's not working because those devices can't complain unless a user coming into the building cannot get into the building. Same aspects with storm control. If there's congestion on the network, if there's congestion to a point where you're actually dropping packets, we can tell you which links those are. Same as the construct with congestion on the uplink. If we identify the uplinks automatically, when is a good time for you to actually go in and start looking at upgrades? We can tell you if all of your sites at a global scale, right? We can actually look at the same metrics at a global scale as well. If all of the devices across all sites, here we have one site, like an organization, but if you have 1,000 sites, imagine how you're able to easily see which is the worst affected site and which are the devices that actually need, which are the sites that need help, and that's the aggregation that we do from all fronts. The last thing I will leave you with is the elements of Marvis actions. We can tell you if there's a loop detected, if we have a host of port flaps that are continuously happening on your network across, and this is an org level. We're looking at 50,000 ports. We're telling you there are 5 bad cables, for example, or 10 devices that are continuously flapping for you to go look at. If there's a host of TCNs from STP, then that's something that we can look at and we aggregate, and we tell you if there's an immediate increase in broadcast and multicast traffic. We actually detect these for you and tell you that there's a problem. So very, very powerful in terms of actions. So that's some of the day 2 stories that we can talk about. For 3 minutes, I forgot to answer one question. What does automation look like? One powerful element that you would see, Eric, is every single click that is done on the code right here is actually an API call. There is nothing that is built that is UI only. Every click that I do, every element that I work on is all an API call. You can type in exactly the devices that you like to look at, and all of them are just APIs in the backend. In fact, if you'd like to look at APIs, feel free. You can actually go in and open it in a new window. This is what the API at the backend looks like. Use your Ansible, use Solr, whatever your favorite automation tool is. You can actually make REST calls, or this is a REST framework on Django. You can use API calls through our cloud, and you can make this all seamlessly integrated into your existing Ansible framework. Having said that, thank you all so much for actually sitting through the entire presentation. We've seen consistent amount of people on the call. That means whatever they saw hopefully was good. And Rajat, any last words?
No, thank you, everybody. If you have any questions, feel free to send them our way. We'll be happy to answer.
All right, let's go ahead and close it out. Thanks so much. You guys have a very good day.